All right, welcome to Module 2, Lesson 2. I'm on page 59, and we're continuing to kind of practice our skills and develop our skills for solving real problems, particularly when they are in the form of a word problem, because you know what? Life's full of word problems. Okay, so we're going to just get right into it. The more practice we have, the better off we're going to be. Suppose that Corey and his friend Walter go to a movie and each of their tickets cost the same amount. And they share a frozen yogurt, gross, that costs $5.50. The total amount they spent is $19.90. So how can you write an equation that describes the situation? Well, first thing I want you to know is that an equation is going to have an equal sign, okay? The word is tells you that the relationship describes an equation. Is means equal, okay? The word total tells you that the operation involved in the relationship is addition. Total means addition. You're adding something up. Okay? And then let's look at the numerical information that we have. Okay? We have that the frozen yogurt costs $5.50. We know that the total amount spent is $19.90. And what the unknown quantity is the cost of the ticket. We know that we bought 2 tickets because one for each guy. But we don't know how much that is. Okay? Okay, so I wrote in all of that stuff that we just mentioned. Now we're going to write a verbal description. It says to choose a name for the variable. It makes sense for us to use C because we're looking for the cost of a ticket. And the verbal description is that you've got twice the cost of a ticket, so 2 tickets, plus the cost of a frozen yogurt equals the total, okay? So to write an equation, write a numerical or an algebraic expression for each quantity and then insert an equal sign into the appropriate place to get your total equation. So let's see if we can do that. Okay, so use C to represent the cost, twice the cost of a ticket, plus the cost of the yogurt equals the total cost. Okay? So to write an equation, write a numerical, or we're going to say an algebraic expression for each quantity, and then insert an equal sign into the appropriate place. Basically, the expression is like the cost of 2 tickets plus the yogurt, so that's one side, and that equals the other expression, which is $19.90. So an equation would be 2 times the cost of a ticket plus the $5.50 equals our total, which is $19.90. Okay, a verbal model can sometimes help you kind of think through. This one was a fairly easy situation, but it becomes more and more important to think these through the more complicated your equations get. Basically, you're thinking, all right, cost of 2 tickets. I know I've got that. I've got the cost of the yogurt. And those 2 things together are going to give me the total. That kind of gives you a verbal model to follow. Okay? And that's kind of what we did, and we translated it. We kind of already did that up here. Okay? All right, number 2 asks, could you write a different equation to describe the situation? And the answer actually is yes. The bottom line is we need to describe what's going on, but there's more than one way we can do that. Originally on our previous page, this was our equation. But I could also say, you know what? I know that the total is $19.90 minus the cost of the yogurt is going to give me the cost of 2 tickets. I could do it that way. Or I could say, you know what? A ticket plus another ticket plus the yogurt gives me the total of $19.90. So, I mean, you know, there's more than one way to write it, but the bottom line is if you think it, if you think it through, you should wind up with an equation that's equivalent to the one that we started with. Okay? And that way the C is going to be the same no matter which way we did it. We've got to think carefully what each part of our equation means. All right, so now we have another one. Aaron and Alice are bowling. Alice's score is twice the difference of Aaron's score and 5. And the sum of their scores is 320. And find each student's bowling score. So we're going to start taking that situation apart piece by piece until we can construct an equation that represents our situation. Okay, so first I know that Aaron and Alice's score together totals 320. Okay, choose a variable for the unknown quantity and write an equation to model the detailed situation. Here's what I'm going to do. It says let A represent Aaron's score. Could it have been Alice instead? Sure, but once you pick one, keep that with. Okay, so A is going to be Aaron's score. A is Aaron. Then you go back up here, Alice's score. So Alice, the word is means equal. Alice's score is twice the difference of Aaron's score and 5. So this is the difference of Aaron's score and 5, and Alice's score is twice the difference of Aaron's and 5. Okay? Okay, so again, I go back. I know that Aaron and Alice together scored a 320. So here's Aaron. Here's how I represent Alice's score. Aaron, sorry, I scratched out the little plus. Aaron's score plus Alice's score is 320. Okay? And I actually, remember, I'm only using one variable because I'm describing Alice's score relative to what Aaron did. That way I only use one variable. And then all you have to do is plug in, distribute. Distribute means I'm going to take that 2 and I'm going to multiply it by the A, take that 2 and multiply it by the -5, and that's what I get here. And then I just combine everything and I can finally come down here, and A, remember, stands for Aaron's score. So 110 is Aaron. I still have to do a little more work to figure out Alice's score. But I know Aaron's is 110, and so I put that 110 right there. 110 minus 5 is 105, and twice 105 is 210. And then you can check that your answer makes sense. Here's Aaron's score, which was 110. Here's Alice's score now that I've done the math. And do they add to 320? Yes, they do. So it makes sense.